Hey guys, welcome back to another Oculus Quest Unity tutorial. In this tutorial, I'm exploring the concept of raycasting quite a bit. You can see I have these laser pointers coming out of my hands here, and these are generated using a raycast and a line renderer superimposed over the raycast. I do think there's a better way to do laser pointer functionality like this, but this was really more of a way for me to explore raycasting than a way to make a perfect laser pointer. As you can see, if both raycasts are pointed at an enemy object for long enough, then it will grow and then eventually explode. And I will spawn that in here. And the way that I've written the code allows you could really make it do anything. So you could, make it hover, you can make it move towards you, you can make it be pushed back away from you. So it's a pretty cool mechanic, and it's very versatile. It can be adapted quite easily. I was inspired for this by the Superhot, a similar functionality in Superhot, which you can see here, where you sort of point both hands at one of the bad guys and then they explode. And I think the mine is implemented a bit differently, but this was the inspiration for it. Okay. So here's what the scene actually looks like. What I'm going to be focusing on, I have a couple of additional things that I'm not really going to go into detail on. That's going to be these prefabs here, which are all used to generate kind of the explosion that happens when the enemies die. And I've also got these prefab scripts down here, which are, some of them I was just referencing, and some of them are just not used at all, or are used for the explosion of the bad guys. So not going to go into that. What I'm going to focus on is these three scripts, beginning with telekinesis, and then I'm just going to show you where these scripts are added and what they're actually doing to create the functionality that we want. So under our enemy prefab, you can see that this prefab comes with the telekinesis explode script. So this is what actually basically tells the enemy to blow up after both raycasts have been pointed to it. Then under our OVR player controller here, which is, again, this is kind of a prefab that comes with the Oculus Integration for Unity, and I go into more detail on how to set this all up in my Oculus Blueprint video. Under this controller, under the left-hand anchor and the right-hand anchor, I've added our two scripts for the telekinesis hand and telekinesis hand left. An interesting thing to note about these two scripts and the dynamics of having one on each hand, I tried making just one script and then adding it to both hands, and that didn't seem to work out super well. Either I ended up with only one of the hands rendering the raycast or the line render, and then the other hand would just not work, or they would both kind of jitter back and forth and create definitely not a good effect. So what I did was I essentially duplicated the code in each of these scripts and then made it specific to the left hand and the right hand. That seemed to be the most functional way to solve that problem, but I would love to hear anyone else's take if they've tried doing something similar or run into a similar problem and how they solved it. One other thing to note is that the telekinesis hand left and telekinesis hand scripts, they also require that you add a line renderer component to your right hand anchor and your left hand anchor. And the line renderer is actually what allows the line to appear. So the raycast is by default invisible, and then we're actually going to be running or sort of drawing this line renderer over the raycast based on the information that it collects for us. And you can think of a raycast as basically it's just a ray being shot out from a point in the scene, and whatever it hits, it then returns that information back to you, so you can do things with that. So you can use it as coordinates. In this case, we're using it as a coordinate for an end position for our line renderer. You can use it as to return information, like we're going to be returning information from these game objects if we hit them. So yeah, just letting you know, you will also need to have a line renderer added here, and then that's going to be added into a public game object slot on the telekinesis hand and telekinesis hand left script. So you can see I basically just dragged this line renderer into here, and that's then we're referencing that in the script. So all that said, let's actually jump into the script and see what's going on here. You can see, like I said, you can see the main difference between the two scripts is going to be really just the OBR input source. So it's almost the same code between telekinesis hand left and telekinesis hand. And the main difference is the where I'm pulling the data from. So this float hand right is getting the OBR input from the right hand trigger, and this float here, hand left, is getting the data from the left hand trigger. We also have a couple key differences, like you can see I have enemy hit left as a boolean set here, and this is just labeled enemy hit here. Again, that's so that telekinesis explode can differentiate between is it the right hand or the left hand that is hitting me as an object, and I'll go through that later. I believe that's all of the main differences between the two scripts. Everything else here is going to be exactly the same. So I'll just run through what we've got going on here. We have to set up our variables and objects before we get into the actual code. So we're setting up a public line renderer, which we already looked at. We're setting up some float information for our line renderer. We're going to have a boolean to check to see if the line render is enabled or disabled. That's going to allow us to hide or show the line render whether we've squeezed the trigger or not on the controller. Obviously, we have our float information from our trigger. We've got a game object labeled enemy that we're going to be using to check to see what we've hit. And then we're also going to have a boolean to detect whether we are hitting an enemy or not. During the start function, we're using these three lines to set up our line render. So we're setting the positions of our line renderer using this empty array, or it's not really an empty array, but this array of vector 3s. So we're creating a vector 3 array called start line positions. That's going to have two vector 3 items in it, and they're both going to be set to 0. And then this will be updated later on in another function. And then we're also setting the line render to false, or setting it to disabled basically, so that it doesn't display until we want it to. Under the update function, we are continuous, so every frame, the update function is going to run every frame. We are continuously getting the new value of the hand trigger, and then we're checking to see if that value is greater than 0.9. So this hand trigger, you can check it out on the Oculus Integration docs. It'll kind of give you everything that the triggers return, but this specific input returns a float value from 0.0 to 1.0, and so we're checking to see if it is greater than 0.9, which is going to be almost all the way pulled in. If it is greater than 0.9, we're going to toggle our variable toggled to true. We're going to enable our line renderer, telekinesis line, and if it is less than that, then we're going to disable both of those things, and we're also going to make sure that we are no longer registering that we've hit an enemy. So enemy hit, that boolean value, we're setting that back to false, just in case it was set to true earlier in a previous frame. And then if toggled is set to true, then we want to run our telekinesis function. So the telekinesis function, we set it up down here, and it takes 3 arguments. So it has transform.position, transform.forward, and line max length. This variable we set up earlier, and then transform.position and transform.forward is just going to take the transform values of your actual left hand anchor, or your right hand anchor, whichever one you're working with. So we're passing those variables into this telekinesis function, and let's see what that function does here. So in our telekinesis function, we're going to be doing three things. We're creating and running the raycast, which is what I actually wanted to focus on. We're going to be rendering the line, and we're also going to be checking to see if the thing that the line hit has the telekinesis explode script added as a component. So let's look at this real quick. We're going to set up a raycast hit, and we're just going to call it hit. We're going to set up our actual ray for our raycast, which is going to be telekinesis out, and you'll note that is taking in the vector 3 target position and the vector 3 direction. So these two things are going to correspond with transform.position and transform.forward. So you can basically see like these two values are passed here, and remember these two values are the values for our left hand anchor and right hand anchor. We have another vector 3 called end position, and basically this is going to be our left hand anchor position plus length times direction, so our line max length and the direction that we passed in earlier. And that's going to calculate the kind of second point for our line renderer to actually draw a line between 2 points. So when we actually run a raycast, this seems to be consistent across all use of the raycast, the physics raycast in Unity. You run it inside an if statement. So if physics.raycast, and then you pass it the ray that you set up here, and you pass it the raycast hit that you set up here. And then that's going to return a bunch of information to us. So if this is happening, then do these things in here. The first thing that we're going to do is we're going to set end position up here equal to hit.point, which is just you can see the tooltip here specifies it as the impact point in the world space where the ray hit the collider. So wherever our raycast hits, that's what we're going to set our end position to up here, and then that's going to be used to draw our line later on. We also want to set the enemy variable that we set up all the way back up here. We set up a game object enemy. We're going to set that equal to the game object for hit.collider.gameObject. So we check to see, did the thing that we hit have a collider, or does the thing that we hit have a collider? And if so, return that game object and then store it in the enemy variable. Then we go in here and we basically want to do an if-else statement. So we want to check to see, okay, so this game object that we hit, does it have the component telekinesis explode? So what we're actually doing is we're sort of pinging this with, or this with the raycast, and then we're checking to see, okay, this game object here, does it have the script telekinesis explode added to it? So like this would not have that script added to it, and this does have that script added to it. So if it does, what we're going to do is we're going to set enemy hit equal to true, because we want to let the telekinesis explode script know that we're hitting it, and then we're actually going to set the Boolean value, so we're actually getting the public Boolean right hand ray from this script, and we're setting that equal to true. So it's basically like we're going over here and we're checking that box and setting it equal to true. And then if we hit it with the left hand ray, we're checking both boxes. So when one raycast hits it, boom, the first Boolean gets set to true, and when the second raycast hits it, the second one gets set to true. However, if the enemy does not have this script added, then we just want to register enemy hit as false. So we're just setting that back to false. So that's everything happening within the raycast. We're creating the raycast, we're updating our end position here, we're updating our enemy, and we're checking for some information about the enemy. Then, if the raycast stops and we're no longer running it, we want to set enemy hit to false, just in case this was still set to true. If it's no longer hitting anything, then we want to set this back to false. And then the very last thing that we're doing in this function is we're actually drawing our line. So we're setting the first position of the line to target position, which is, again, just the transform.position that was passed in here. So target position is going to equal the hand anchor, and then end position is going to equal the hit point where our raycast hit. So that's where we're drawing the line. And so all of this only runs if we've pulled down the hand trigger and set toggled equal to true. Okay, so that's a lot. It doesn't quite make sense yet, I don't think, but once I go through the telekinesis explode script, I think it will all start to kind of click into place. So let's take a look at that. Okay, so under the telekinesis, we're on telekinesis hand still. Telekinesis explode. This script should be added to whatever you want to be impacted by the two raycasts. Let's just go through what we have set up here. So we have a public game object, cube shattered, which is a prefab that we're using. Let's look at this guy here. This is just a prefab that we're using to make it blow up after it is destroyed. We have our right hand ray and our left hand ray, which we just looked at. So that's going to be these two booleans, and those are set to public so that other scripts can access these values. We have a couple of private floats, and these are just going to be used to make the object grow in size, like you saw earlier. We have two booleans, one to check to see if the object has died yet, and one to basically it's a flag for our countdown to see if we've completed the countdown for the enemy to die. We want there to be a small amount of time where both raycasts have to be pointing at the object and it's growing and growing, and then it explodes. If we didn't have this time tracking set of variables here, then just as soon as you pointed both raycasts to the object, it would immediately blow up, which is not what we want. So we have a time variable, we have a sort of max time or explode countdown here, which is how long we want to wait until the enemy dies, and then we have a boolean to check to see if we've exceeded that countdown. So in our update function, we have a lot of if statements here you can see. The first thing we're doing is we're just checking to see is time greater than explode countdown. So has this float counted up greater than 3, and if it has, we want to set countdown equal to false. We want to run our explode script here. We want to check to see, this is actually pretty important, these two if statements here, and these are what you would need even if you're not doing any of the other functionality that I have in the script. These are probably the most important ones to focus on. What we're doing is we're checking the telekinesis hand script and the telekinesis hand left script, and we're checking this enemy hit variable or boolean. We can see that listed here. Enemy hit left turned on or off, and enemy hit turned on or off. What we want to check is we want to know if that's set to false so that we can set our right hand ray back to false and our left hand ray back to false. If we didn't do this, what would happen is our raycast would hit an enemy, and it would toggle right hand ray to true, but then it could go on and hit something else in the scene, and there's no logic in these scripts to tell it to go back to false, and this script really can't detect if it's not hitting that. So we have to have the telekinesis explode script detect that. So if the raycast leaves this object, then we want to uncheck that. Otherwise, we could hit the object, go point at something else in the scene, and then the left hand raycast could come along and hit it separately toggle this on, and then it would start the explosion process. So we want a way to set this Boolean back to false if the raycast stops hitting our object. So we're doing that here, and then the last thing we're doing is we're just going to say, if countdown is false, kill the enemy. Finally, under our trigger explosion function, we're doing two things. We're checking to see if the right hand ray and the left hand ray and our countdown Boolean, if those are all set to true, then we want to slowly scale up our game object, and we want to increase our timer by time.delta time. So we're just plus equalsing. And then so if both the rays are pointing at the object, then we're slowly going to count up our time, and we're slowly going to grow the game object. And once our time increases past 3, then countdown ticks to false, and then once it's false, the enemy dies, and if enemy die equals true, then we basically instantiate our exploding set of cubes, and we destroy the actual game object itself. And of course, you could put pretty much anything else in here that you wanted. You could make it, in here, you could make this be like, you could make it hover, you could make it spin, you could make it turn into something else. There's a lot of stuff you could do in place of what I have here, so it's pretty exciting dynamic, I think. And that is all I've got. As always, I'd love to hear feedback or questions or ways that I could improve this or write my code better. So thank you, and hope you enjoyed.